There we go. Okay, so yesterday we looked at composition. Who showed it up?
Oh, well, probably. I
Okay,
came back and then
good thing that it doesn't really matter
I
today.
accidentally bumped it.
All right, composition, what something's made of. So we have two categories. We have the pure and we have the mixtures. So it's gonna be like your elements in those very specific compounds. Most everything is gonna be mixtures because it doesn't matter how like the proportion or like it's just, they can just be like added in. It doesn't have to be anything set or very regulated. With our mixtures, we have two types of those. We have our homogeneous and we have our heterogeneous. What does the prefix homo mean? Same or different?
Same.
Okay, hetero means different. All right, so if a mixture is the same throughout, it's homogeneously mixed, and a type of mixture that is homogeneously mixed is a solution. Okay, so a solution is a specific type of homogeneous or homogeneous mixture. It looks the same throughout, and this is true anytime you add a second phase, like by putting maybe ice cubes in. That would make it a second phase, which would make it heterogeneously mixed. So even though ice cubes and water are the same compound, right, H2O, you're having two different phases in one, that means it would be something that would be considered heterogeneous. Because if I can see the ice cube and I can see the liquid, that's two things, making it different, turning it hetero. So solutions cannot have ice cubes. So if I have my Kool-Aid here, if I put an ice cube in it, then it would no longer technically be a homogeneous mixture because it now has two states of matter. So solutions are going to be just homogeneous mixtures, everything looking the same throughout. And we're going to talk a lot more about solutions tomorrow, a lot more of those S words that I keep talking about. We have so many of them this unit. And then we also have these things called suspensions, where you're dealing with two states of matter, typically the solid and the liquid. And just like my bottle here, when I shake it, right, it is able to hold and carry the pebbles and the stones that are in it, right? So this is considered technically a suspension because it's able to hold up, and there's different states. We have solids and we have liquids in this thing, okay? Right now, the real fine particles in dirt are suspended in this liquid. They are held up. When you saw it before it got shaken, the water had kind of cleared out, right? Because more of that had settled over time. All right, colloids, not too concerned about. Here's the information for today. So I've been saying all along, we can separate out mixtures by using physical characteristics and properties. So we're going to talk about a few major ways to do this. All right, so one way is that you could stir something with a magnet or like run a magnet over it, and from there you would be able to identify if something is magnetic or something is not magnetic. I know my group, we talked about this last year, like at junkyards. They have giant electromagnets that they can put over like a pile where things have been dumped, and that big magnet goes over the pile. They flip a switch, it becomes magnetic. Anything that is magnetic in the pile will be attracted to that big pad, and then that pad can then get moved, turn the switch off, and it drops everything that was magnetic. So instead of like having to like hand sift through the material, they're able to go through and, you know, just use that electromagnet to grab everything that is magnetic out of that pile and leaving the non-magnetic stuff. So the property that would be used in this situation would be magnetism. Keep this in mind because as we'll have a lab here pretty soon where, again, you're going to be given a container with a mixture of items. You're going to have to use some of these physical properties to separate the mixture out because there's like 5 or 6 unique items, and they're all going to have to get separated out into their individual containers, and you're going to have to use physical properties to do that. All right, so I kind of mentioned a centrifuge yesterday. A centrifuge is a device that separates a solid from a liquid by spinning tubes in a circle, kind of like a washing machine will spin. If you've ever done laundry, where do your clothes end up when the wash cycle is finished? they're on the sides, right? That's because it's using that centrifugal force, which pulls the items to the side. Well, if you have a centrifuge machine, and we're gonna watch a video that shows us here in a minute, it spins kind of like that washer drum, and it's gonna pull any of the sediments that are in the liquid to the bottom. It like helps speed up the density process, that settling. So if you don't have days and days and days to wait, I could put this in a centrifuge, and then I'd be able to have it all layered out. We can be patient and wait it out because it's not like we need it for anything, but like if you have blood work done, you don't want to have to wait days and days if you're sick for them to be able to run different tests, and they have to separate the blood out usually to run a lot of those tests. I did get another picture that I added. I want to go back and show you real quick. So we had talked about the blood. So this is liquid, regular blood that's mixed. This is after it's gone through the centrifuge, and you have all your red blood cells. This is a real platelet-rich area of plasma, and then this is just the regular plasma that doesn't have many platelets in it. So these are kind of the three main parts of your blood. So just wanted to show you that. Okay, so the centrifuge looks like this, and you can put the tubes in, and again, it just speeds up that settling process and is able to separate things out based on density, but it just speeds that process up. Right? So the property that's actually being used here is density. Because the more dense material goes to the bottom, the least dense goes to the top. And then finally, there's something called filtration. This can be done a lot of different ways. So filtration is a removal of a solid from a liquid. Right, so think of like making spaghetti noodles or ramen noodles, right? We fight. She calls them ramen. Everybody else calls them ramen. They're ramen noodles. They're ramen. Anyways, all right, I'm outvoted. They, the noodles are left in the strainer, right? And the water can pass through. Why don't the noodles go through the strainer? They don't fit. So it's size, right? If the holes were like this big, would the noodles go through? Sure, it wouldn't be a very good strainer because you're trying to let that liquid pass through, and you're trying to keep the other bigger item from going through. So you're trying to separate it, but what you're doing is you're using size to make that happen, okay? So size can be another very big way. So coffee grounds, right? If you put the coffee grounds here and the water drips through, you don't want a coffee pot full of coffee grounds. You just want the coffee flavor, which is why the water drips through, gets the flavor from the coffee grounds, and then goes into the pot, and then you can drink the coffee without having a mouthful of grounds.
Which is the best part, you know?
I mean, the best part, right? Okay. So that is, let's see, yeah, we're gonna stop right there. Ugh.